Hello, thank you. All right, it's afternoon. I know it gets a little sleepy after lunch. I've got a lot of content, and it's super rapid fire. So hopefully it'll wake you up. So if you don't know who DataRobot is, let me just take a second to introduce who DataRobot is. We are the pure-play AI lifecycle management platform. We are the only one. We are the category creators of automated machine learning and ML ops. We are trusted by hundreds of and thousands of data science teams and organizations and data leaders across the Fortune 500, from some of the biggest well-known box brands that you've heard from manufacturing, such as car manufacturers out of Japan, to financial firms, both in London and the US, who have standardized on the DataRobot platform for all of their model management, governance, documentation, and regulatory requirements. And because we have been so hardened for highly regulated organizations, we also do a lot with healthcare providers in terms of helping them push the boundaries of using AI for diagnostics and better healthcare. And of course, we have the biggest retailers and CPGs that you would probably recognize anywhere else. And because of our core competency across our industries, we are listed as a trusted partner for our technology alliances. They do see us as their platform of choice, particularly when it comes to applied AI. All right, enough about DataRobot. Tell you a little story. So I was just in Las Vegas at an AI conference talking. And I don't know what it is about me. People want to go gambling with me. I'm not Lady Luck, let's just be clear about that. And I'm absolutely horrible at gambling. Like, my gambling experience is abysmal. I mean, my only card games I actually know how to play are Uno and Speed. So you can realistically understand, like, my capabilities at poker are absolutely awful. But every time I go, someone's like, no, come play with me. I'll show you. It'll be great. And what happens is I just really don't know when to double down and when to walk away. And why am I bringing this up? Well, this is exactly the experience that a lot of business executives have when it comes to their investments in AI and machine learning. They don't really understand when to double down and when to walk away, and what projects are going to make the most sense for them. What they've been sold is this glamorous experience of you're going to double your money, you're going to optimize, and you're going to get so much value out of AI and machine learning. But we all know it's a little bit harder than that. And what's happened is, through the hype cycle of AI and machine learning, we are squarely in the trough of disillusionment. And now, this wouldn't necessarily be an issue. We're all used to this. But the problem is it's being compounded by the fact that we're actually heading into an economic downturn at the same time. So the thing that I hear from business C-level executives everywhere is that they're looking to optimize cost within their organizations to hedge against anything that may happen in the future. And what happens is no team is out from underneath the microscope. And that includes data science organizations. And this is the first time that I think that I've seen this in the last several years, is entire data science teams are actually being completely eliminated from an organization. And that's because they've lost the connection of being able to drive value to the business and being able to articulate that value to the business. And so the best defense is a strong offense as we go into this next wave of AI and machine learning, and making sure that you're being able to hedge against any of these cost-cutting measures across your organization. So we have thousands of customers everywhere. We've seen this multiple times. We've worked with them through all of their maturity cycle. So we know where all of the actual road bumps are going to hit, particularly as you're moving through your maturity cycle. Now, one of the things that we've learned is it doesn't matter the overall maturity of your organization. You have to look at the maturity of each department differently. So your overall company may be quite mature, but if you're standing up and starting to work with a new department, let's say it's marketing or HR, and they've never done AI and machine learning before, you're going to have to treat them as if they're level 1. But there are some key learnings, whether you're just getting started or if you're working with teams that are just getting started, or if you're extremely mature, that we've seen over the course of our working with customers. So the first one and roadblock that we see a lot of the time is overcomplicated AI. There's how it started, and then there's actually how it's going. So how it starts, data science teams, really great at working on cutting-edge algorithms, but they lost a little bit of the connectivity to the business impact that they're trying to drive. So what ends up happening is, oftentimes, a lot of these projects get really, really robust technically, but they're missing the mark. They're getting overly complex. They don't have the data with the context. They don't have the business context. So what the business gets is models that don't meet their needs. They have maybe monitoring hasn't been incorporated in part of this process. How critical is it to the business to ensure that they're getting the right insights at the right time and it's staying accurate as they use it? You got notebooks that are getting thrown over the fence to IT. Go ahead, punt. Go ahead and code this up. I don't know what to do with it. You got a lot of that in organizations. No documentation, which is a really bad thing, especially right now with the turnover of data science teams. So you've got a new data scientist starting, and you're like, we have this model in production that's driving millions of dollars that's going through it in terms of what it's delivering, but we don't know who built it, how it built it, anything about it. And then obviously needlessly complex. So there are so many times that I've seen a neural network being built for the most simplest problem, and then there's no actual path to maintain that once it's in production. So one of the things that we recommend is moving beyond model-centric AI to problem-centric AI. And I know one of the keynotes this morning was talking about value-centric AI. Problem-centric AI is taking that concept one step further. Because you can create value-centric AI in a churn model. Understanding the probability of your customer churning, a customer A churning is 80% is great. That's valuable. We know which customers are going to churn. Why are they going to churn? What are the leading indicators of them churning? What does their churn pattern look like and their behavior look like 3 months before they churn, 6 months before they churn, and 12 months before they churn? Can you mitigate things? What's the causality of the model? And that is what problem-centric AI is about. It's about sprints. It's about focusing on the different problem framings, and it's about driving business value, not just, look, we can prevent churn by X percentage, but here are the leading indicators for you as an organization that our customers are showcasing over the course of their time with us that are actually going to cause them to churn, so they can actually go do something about it. But that takes a different mind frame. You have to change the way you think about your technology, and you have to change the way that you think about your process. When it comes to your technology, you want to really take a hard look at what you're investing in there. We got a little bit of the tech tail wagging the dog lately with AI and machine learning. You have to look at it and understand, is this shrinking my AI cycle time? Is it helping me rapidly prototype, experiment, and get to the causality much faster and being able to explain that out to my business executives? And is this stitching together everything that I have currently invested in my ecosystem? If you can do all those things, what you're going to be able to do is streamline the entire AI lifecycle management. Then it comes to the process side of the house. It begins always with the problem. Now, this is a translation issue that we tend to see between data science organizations and business teams. You have to work closely with your business sponsor, not just at the beginning of the actual problem identification process, but throughout the actual building, and then once you get it out into production. And you want to make sure that there is a dollar amount associated with the value of that model that you are creating or that business problem that you are trying to solve. And you have to work backwards from the adoption to deployment. So let's talk about long AI cycle time. So this is a newer concept that we are starting to see organizations actually embrace, and our customers in particular. So what do I mean by cycle time? Cycle time, if you're from manufacturing, you're very familiar with this concept. It's taking raw goods to finished product, and you're trying to shrink that timeline as tight as possible. This is very applicable to machine learning and AI projects. You want to take a look and measure exactly how much time it takes you at the start of your first task all the way through the insights or deployment. Now, I'm decoupling those two things because, again, sometimes you don't need to deploy. Sometimes finding that causality is enough information for the business to take a change action against, like churn. If we activate and reach out to a customer 3 months before their renewal date, they're not going to churn. Fabulous. That's an insight. And AI cycle times are extremely important, especially right now. So on average, a cycle time can be 11 months. Let's put that in business context. 11 months is almost a quarter later from when you actually took on the project with your business. The impact and the value that your business is getting is completely eroded at this point. The trust is eroded. They don't want to wait another quarter. They're on to the next quarter to try and execute on their plans of what they're trying to do. And also 11 months in what's happened in the last year during COVID with this big, huge black swan event that we didn't expect, we're now getting this ripple through effect of a bunch of gray swan events. And there's no industry that actually is immune from this. There's not a lot of seasonality in anything. So your problem that you try to start at the beginning of 11 months, by the time you finish that and you're trying to get into production, the world is completely changed. Is it actually going to be relevant, or have you lost the actual value of the work that you were initially trying to do? And then from a cost perspective, remember, we're looking at this from an optimization. So if you look at your AI cycle time, and if we conservatively estimate what the cost is, you take your average data science salary, you're looking at the storage and compute, plus some of the part-time work for machine learning engineers, IT, to get that operationalized. An 11-month cycle time is $164,000 on average. $164,000. That's more than the salary of your data scientists that you pay for. Of course, your business executives are going to take a magnifying glass on the data science team and ask, what value are you really giving me as fast as possible? You shrink that down to 2-month cycle time, you're rocking and rolling. You got a $30K per model deployment. You're able to articulate that ROI to your business executives. The other reason why cycle time is extremely important is data science turnover. So the average tenure of data scientists now in an organization is 19 months. That means on a good day, you can get 1 model out of a data scientist before you lose them. And you lose all that IP, especially if you haven't documented it all and you standardize the way that you document, the way that you build models. Take you about 3 months to hire a new data scientist. They're going to have new ways of wanting to approach a problem. You got another 19 months out of them. Maybe you got 33 months, 1 problem. Instead of getting 3 models in 11 months, you've only got 2. This is why business executives are really scrutinizing data science teams and organizations. You have to shrink your cycle time on your AI machine learning to ensure that you're building trust and driving value for your organization. But the problem is a lot of organizations tend to look at just the data prep side of the house. I know it's the most boring part of the entire process, but the reality of it is you can actually automate beyond just the data prep. You can automate your feature engineering pipelines. You can automate your experimentation pipelines. You can create model factories. And then you can continue on to automating documentation, deployment, monitoring, and retraining. And this is why our customers have standardized on DataRobot to be able to shrink this AI cycle time that they have, because we can't automate all of this. And what they tell us is it goes from them taking on data science projects from this kind of horse and buggy cart where they're hand coding everything up to really being able to drive around super quickly, find new paths to be able to drive value, and be able to take on more project workloads. Now, one of the things I do get asked all the time is, but Lisa, we can't automate every single problem. And I'm like, you're right. There are going to be use cases that are very bespoke R&D innovation tasks that you're going to take on as an organization that are going to set you apart from the other organizations in terms of what you're trying to drive from an AI machine learning investment. In those cases, you do want to actually hand code. It's not going to be enough to automate it. But that's the issue. You have to start aligning your effort to impact. One of the things that we see is there is a huge disconnect here. So what do I mean with this? If you're taking on problem-centric AI use cases, the effort to create these for your business should be only 20%, but they should account for 80% of the deployments that you have in your organization. Now, where you want your true data science team and their talent to come is in the ML, R&D, and true innovation aspects. And of course, that's going to be a harder problem for you to solve. So it should account for 80% of the actual effort, even though fundamentally you're only going to probably deploy 20% of those into production. And this is how you start to balance it. You want to make sure that you're using automation where it matters and using your hand coding and bespoke skills where it's needed. So your problem-centric AI, what it requires to move into this is you want to be able to have standardized use case documentation and input. You want to standardize that feature engineering pipelines. You want to standardize and automate the algo creation, the selection, and be able to hand tune those to the problems that you're looking for. And most importantly, you want to standardize the auditability, the risk, the trust, and the governance of it, and make sure that it's performing in production as you want. This frees up you and your team to actually take on some of the cool stuff, which is the ML and R&D innovation. And this is where you're going to want to spend most of your time, because realistically, this is what data scientists really like to do. You want to do the fun new algorithms. You want to do the net new data creation. You want to push the boundaries of what's possible within data science and AI and machine learning, but it requires you to offload all that problem-centric AI stuff through the power of automation. But most importantly, once you get to the end of this and you actually start to deploy this, you should standardize on the production and governance. Just like you do for your bespoke innovation, it should be the same for your problem-centric AI machine learning problems. Now, the last thing that we see is a translation challenge. How do you get to this problem-centric AI? How do you deliver the value? What data scientists are really good at is interpreting and understanding the performance of a model. What I see the gap is taking that, translating it up to the C-level business executive strategy for the organization, and being able to map those two together. As data scientist organizations start to mature and really drive value, you have to act as a translator. There was a session recently over here with at HEB just gave, and they were talking about just this. It's about explaining, and it's about driving business change. So how do you do that? The challenge is you've got lots of cooks in the AI machine learning kitchen. You've got the executive who wants to do the big moonshot approach. You've got the AI creators who are like, I want to build it this way. You've got your implementers who are like, nope, I don't want to implement a neural network. That's not going to work for me. We don't have the ability to take that on. And then you have your business consumers who are like, I just want to know which of my customers are going to churn when and why. Just give me a simple answer. So the best way that we found is to help you guide your translation is to ensure that you have a standardized intake for your use cases. You want to look and start from the business outcome and impact. This is that problem-centric AI. Now, most of you probably have something like this. It's not unique and new. But these are the areas that we see are gaps within organizations that they don't address when they're doing this use case intake. Does this use case have strategic value to the organization? If it does have strategic value to the organization, you're naturally going to get alignment across all of the stakeholders who need to be built there. The other thing is, it's kind of funny. In this last year, I don't know what happened, but everyone's like, only 1 in 3 models make it into production. I'm like, yes. Did you take into consideration where it was going to be deployed, and did you clear the path to deployment before you even started the project? And I don't get a lot of yeses there. And you have to be able to look not just at the technical feasibility and as the data feasibility, but in the production of it. Is that ready? If it's aligned to a strategic business initiative, if you have a quantifiable ROI, you have the business case to actually get the resources aligned and the path to production cleared out for you before you even take on the project, so you don't run into this effort of, I've built it and I've got nowhere to go. And the last thing is about making sure that you're retraining models in production. So how do you translate that? So this is something that DataRobot we do. This is our template that we work with customers all the time. This is a translation guide between data science teams and executives. As you can see, there's nothing data science here. The only data scientist words here is predict the target, and then maybe the feasibility for you. But you understand this. It's your job to help elicit out of your business team what it is that they want, and then get an ROI. If you do this well, you start to build this cadence and this relationship between your business leaders and yourself as a data team. And what you end up is hundreds of those little cards that are mapped across very different departments that you can do as a use case prioritization. Now, you definitely want this use case prioritization because you as data scientists and AI experts will understand that some of these problems, as you start to uncover them and go after them, there's going to be no signal. This is the other reason why you want to shorten that AI cycle time. You want to get to this isn't going to work faster. Could you imagine taking 11 months for a business to wait, and then you're going, sorry, we didn't derive any insights. That erodes trust between you and your business teams. It doesn't set up that partnership that you're looking for. So you want to have a few of these so you can help your business understand, let's go down on this path, or this one didn't actually have any signal. The other thing that we see is a lot of ad hoc modeling. So you're doing an HR project, maybe an ops project, maybe a marketing project. The reality of it is, if you have that use case matrix mapped out, you can actually daisy chain this. And this is how you can start to create really compounding value. So your demand forecasting model will influence your raw material supply model, which influence your supply chain model. And all of a sudden, you're daisy chaining these out, and you're rapidly quick-firing, giving value to your business, and you're not waiting 11 months. You're helping them understand how you can give them all along their business value chain with AI machine learning. The other thing is, this is about narrowing that conversation with business and data science. So this is a DataRobot platform. What you're seeing here is a profit matrix. Work with your business executive to help they influence exactly how much that they're willing to either have in terms of a risk trade-off, and let that influence what the model actually looks like versus via vice versa. So this is something that we do have. The other thing is making sure that you're tracking the progress of your value. So again, this is within the DataRobot platform. It's being able to look at every single project that you have out there, what stage it is, and what the value is, so that you can quickly create an executive-level dashboard review of what's happening. Now let's see this in real life. This is Nestle Mexico. Nestle Mexico is a sub-branch of Nestle, and they were much more in the later stages, the early stages of the maturity cycle. So this is a little bit of an eye chart, but everything above the line is what Nestlé Mexico did with the DataRobot platform. Everything below the line is what we helped them coach them on. Now, what you can't see, because it's very small here, is the team is only 4. So it's a 4 team, 1 data scientist, 3 analysts, but in a matter of 12 weeks, they had 4 projects out. It's because they broke down and daisy-chained the problems together. What ends up happening is a lot of organizations, what you start with is they want the pricing optimization, and we go, great, let's go do the pricing optimization. But to do pricing optimization, you need price elasticity, and you need a little bit of market share, and guess what? You need demand forecasting. So start with the demand forecasting. Build out the value quite quickly. Also break down that problem. With Nestlé Mexico, they were trying to optimize on the most margins that were going to drive profitability to their organization. They didn't need SKU-level details and demand forecasts across every single of their product immediately. So break down the problem into bite-sized chunks. Rapidly deliver value. So get that first wave of demand forecasting out, then add the second set of categories, then add more data to it to harden up the forecast, and then continue to move from right to left. All right, but then this leads to a maintenance headache. So if you're doing this right, you've got great business alignment, you've got a backlog of use cases, you've got models that you've got out into production, and now you're stuck. What do? Do you take on brand new models? Do you go back and do you rebuild the models that you have in production? And it's a huge trade-off here. And you want to make sure that you're balancing this out. Models in production is stuff that your business users are actually engaging with. And if they lose trust in how that model is performing even one time, that erodes your trust with them. And we see this all the time. Data science teams spend weeks and months trying to get the best performance accuracy. Then they put it out into production and they never retrain it. The reality of it is if you only got it to 70% accuracy and you put it out into production, your average accuracy over time would be actually better than the average accuracy when you got it to the level it needed to be and put it in production. And the other thing is when you're remodeling is you have to try different models. It's not enough to actually just rebuild it with new data. You have to do different time periods, do different pre-processing steps. This is extremely important for maintaining the trust within your business executives and you. One of the things is, as humans, we are hardwired to trust our guts. You know, I just always ask, like, how many of you trust Waze 100% of the time, all the time, and never deviate from the path it gives you? I see a smile there. Yeah. And we're at an AI and machine learning conference, so we know that Waze is going to tell us better, and then we decided we're going to trust our gut, and we're going to be 5 minutes late now when we should have been there on time. Why do we do this? It's because it's what helps us prevent us from getting eaten in forests when we're like, I don't see a predator, but I feel a predator. We're just intrinsically hardwired to trust our guts. And so if your users actually see your model fail in production once, they're less likely to use it again. And I heard this, I was on a call, it made me so sad. Data science team puts a model into production. It actually decays over 3 months. Their business users stop using it after 2 weeks because they don't trust it. But he doesn't have a continuous AI plan in place. So you have to be able to modernize the second half of this life cycle. It's not enough just to do the first half. You have to shrink the cycle time, and this is what helps you maintain the value, maintain trust, maintain adoption within your AI and machine learning initiatives. Now, the other thing that we see is, let's be honest, everybody's AI machine learning infrastructure is a hot mess. It just is. You've been building this organically over time. We haven't had standardized process. It literally looks like this. It's a hot wire. This is a real view of it. It's not just to be realistic about it. The current machine learning process delivery, it's complicated, it's brittle, it's costly, and what's worse is if you're part of a big organization, this entire schematic is probably different across different departments that you have. And then if you acquire a company, now you're trying to absorb their actual infrastructure. If you're on-prem and you're trying to move to the cloud, this is a nightmare. If you're trying to move between clouds, this is a nightmare. What DataRobot has done is we help you build a technical AI center of excellence. The reason why you have a hot mess of IT infrastructure and AI machine learning pipelines is because there's been an over-indexing on creating a people center of excellence. Now, the reality of it is, as your organization matures and changes over time, your people and the way that you're structuring the team is actually going to fluctuate. You may be all centralized. You may be hub and spoke. You may be disparate. But you're not building a technical center of excellence, which is what leads you to that hot mess. And this is why all of the biggest financial firms are standardizing on DataRobot. They have custom-built hand models that they're doing from an R&D innovation perspective. They're using DataRobot to shorten that AI cycle time, but they're standardizing and getting a single source of truth. So all of their AI artifacts are in one place. You have governance, you have visibility, you have transparency, you have lifecycle management, and then you're ensuring that those models are getting out to the right places at the right time. And this is what streamlines your value and ensures that you're maintaining your value independent of how mature and how big your teams get and the more models that you take on. Thank you very much. That was a very rapid-fire session. If you'd like to learn more, if you'd like to dive in a bit more about any of these concepts, we actually are in meeting room 4. I'll be there along with some of my other team, just straight down that hall. Or you can learn more about DataRobot at datarobot.com. Thank you.